plus b. So let's do some problems. If I have 5 to the 3/8 times 5 to the negative 1/8 times 5 to the 2/8. So a couple of things we want to make sure of. We want to make sure they all have the same base. Do they all have the same base? Yes. Next thing we want to make sure of, because the rule says keep your base and add your exponents. So what do we want to make sure? All the denominators are the same. So the denominators are the same. So now we can absolutely multiply. We keep our base of 5 and then we add our exponents. 3 minus 1 is 2. 2 plus 2 is 4. So if I have 5 to the 4/8 power, what does that simplify down to? 5 raised to the half power. And remember, on the test, I'm going to make you write everything as a radical. So how do I write 5 to the half power as a radical? Square root of 5. You got it. So if I have the 5th root of x times the square root of x, if you remember last class, I had told you that all your answers on the test will be asked to be written in radical form, but there's times we can't solve the problem in radical form. So you'll need to change it to exponential and then change back to a radical. This is a scenario like that. So I have the 5th root of x times the square root of x. Can I multiply if their indexes are different? No, and I can't change their index in radical form, but can I change the index in exponential form? Absolutely. So what we're going to do is we're going to change these into exponential. So I have x raised to the 1/5 power times x raised to the half power. And now we're going to create that common denominator where here the common denominator is 9, not 9, 10. The common denominator is 10. So I have x to the 2/10 power times x to the 5/10 power. And now can we simplify? Now can we multiply, I should say. Yep, we're going to have x to the 7/10 power. Can I reduce 7 over 10? No. So now we're going to write it as a radical. So it's going to be the 10th root of x to the 7th power. If at this point I could simplify the radical, would I have to? Yeah. Say I have the cubed root of 9 times the square root of 3. So we have a couple of issues here. Not only do we have different indexes, what else do we have different? Radicands, or if an exponential, the base, exactly. So I'm first going to change it to exponential since I know I can't deal with the radical no matter what. So I'm going to have 9 raised to the 1/3 power times 3 raised to the half power. My first question for myself is, can I change these into the same base? Because if I can't change them into the same base, then no matter what, I can't multiply. So can I change 9 into a base of 3? Absolutely. So this becomes 3 to the 2nd raised to the 1/3 power times 3 raised to the half power. So now I have 3 raised to the 2/3 power times 3 to the half power. Now that they have the same base, now I can create the same index. How do I create the same index? Stephen? Yeah, we make a common denominator of 6. So this becomes 3 to the 4/6 power times 3 to the 3/6 power. And now we can multiply. Do we agree this is going to be 3 raised to the 7/6 power? And now when I write this as a radical, this is going to be the 6th root of 3 to the 7th. Well, guess what? we can simplify this, right? So if I have the 6th root of 3 to the 7th power, can I take a group of 3s out, right? I have a group of 6 3s. So we're going to take 1 3 out. And so I have 3 times the 6th root of 3. You guys try this one. Oh, guys, there's not so much homework. The worksheet's optional. It's not part of the homework. It's optional. So it's just textbook pages. It's not that bad. Let me see how many problems there are. I mean, there's still like maybe like 18, 19 problems. I'll still give you double. Oh, wait, guys, didn't we do this problem yesterday? We did do this problem yesterday. All right, we're doing it again. This is 4 raised to the 1/4 power. Yep. Minus 2 to the half power, because I was jumping around yesterday. And then we need the same base, so we're going to change this into a base of 2. So this is 2 to the 2nd raised to the 1/4 minus 2 to the half. So this will be 2 to the 2/4 minus 2 to the half. Well, 2 to the 2/4 is 2 to the half raised to the half power. And what happens when you take a quantity away from itself? It's just 0. We did this. This was the last problem we did yesterday. All right, last problem for multiplication. Actually, can I distribute in this exponent of 2? No. What do I have to do? We have to FOIL. But when I go to FOIL, can I multiply terms that have different indexes? No, I can't. So I'm going to have to change this into what? Exponential. I need to change this into exponential. So this becomes x to the 3/4 plus y to the 1/6 times x to the 3/4 plus y to the 1/6. And now we need to create a common what? Denominator. What's our common denominator here? 12. So we're going to have x to the 9/12 plus y to the 2/12. And then again, x to the 9/12 plus y to the 2/12. And now we FOIL. So x to the 9/12 times x to the 9/12 is going to be x to the 18/12. I'm going to leave it like this until the end. X to the 9/12 times y to the 2/12 is going to be x to the 9/12, y to the 2/12, right? Just multiply them together. Why am I not adding their exponents? Because their bases are different, exactly. So we just put them next to each other to show multiplication. And now we're going to do the y to the 2/12 times x to the 9/12, which once again is x to the 9/12, y to the 2/12. And then lastly, we're going to get y to the 2/12 times y to the 2/12 is going to be y to the 4/12. Are we good so far? Everybody good? Okay. I'm going to combine my like terms right here, right? So I have this whole quantity and this whole quantity. Isn't there a 1 in front of each of these? So I'm going to have x to the 18/12 plus 2 times x to the 9/12 y to the 2/12 plus y to the 4/12. Because I can only put this middle term under the same radical, I'm going to keep them with a denominator of 12 to keep them in the same radical. But what I'm going to do here, x to the raised to the 18/12 and y to the 4/12, I'm going to simplify those exponents. So 18/12 can simplify down to what? Good. I could divide top and bottom by 6, so we get a 3/2. And then y raised to the 4/12 can simplify down to 1/3, right? So now we have to write this as a radical because remember I told you all the answers are going to be in radical form. So this is going to be the square root of x to the 3rd plus 2 times the 12th root of x to the 9th y to the 2nd plus the cubed root of y. Am I finished here? Good. Why no? Good. The square root of x cubed, I can pull out an x. So this is x root x plus 2 times the 12th root of x to the 9th y to the 2nd plus the cubed root of y. All right.
So is it wrong if we don't like simplify the like as in like if we have like x to the 4th and x squared, that's wrong.
Yeah.
Because it's close enough.
Correct. Stephen? Yes. Carly?
Like just to be clear, like when we talked like before, it's gonna be like the common denominator of like all. Like if it isn't squared and they're all like different.
Yeah, we would make a common denominator for all of them because they're all going to be multiplied together. All right, let's talk about dividing.
Root, it's an adding. It's root 3a plus the 4th root of 9 squared minus 12a.
Okay, you want me to go over that problem again? Okay, so for this, in order for us to be able to add, you need the same index and you need the same radicand, right? I do notice this 12a to the 3rd, I can simplify this. So 12 becomes 4 and 3, 4 becomes 2 and 2. So this becomes a 2a root 3a. And then I have the 4th root of 9a squared, which is a major problem for a couple of reasons. And then I have the square root of 3a. So right now I can add these two together, right? But can I add that middle term? No, because it has a different index and it has a different radicand. So what I'm going to do is I'm going to try to change them. Well, I guess I can add the like terms to start. So I would have 1 minus 2a, if we're adding these two, root 3a, plus the fourth root of 9a squared. Okay, so now what I'm going to try to do is I'm going to try to see if I can make this similar to this. So I'm going to change it to exponential. So I have a 9a squared raised to the 1/4 power. Okay, so now for this, I need to make this into a base of 3a. Can I change 9a squared into a base of 3a? Yeah, if I make 3a raised to the second power raised to the 1/4. So 3a squared is 9a squared. So now I've created that same radicand. So now I'm going to have 3a raised to the 2/4 power, which is the same, 2/4 is the same as what? A half. So now I have 3a raised to the half power. So now this becomes, over here, we had, what was it that I had added to? Thank you. 1 minus 2a times the root of 3a plus or minus this plus. Okay, so now I have 1 minus 2a root 3a plus the square root of 3a. So there's another one, right? So now we could add the coefficients again. So I'd have 2 minus 2a times the square root of 3a. Okay? Okay, quotients. Okay, so the rule for dividing, which we all know, if I have x raised to the a power divided by x raised to the b power, we are going to get x raised to the a minus b power. So let's say I have x to the 8/9 divided by x to the 2/9. So this isn't so bad because I have the same base and I have the same denominator on my exponents, right? So the rule says just keep your base and subtract your exponents. So 8/9 minus 2/9 is 6/9. But what do I have to do to that 6/9? Simplify it. So that becomes 2/3. And how would I change x raised to the 2/3 into a radical? Cubed root of x squared. X to the 2/3 over y to the half, all raised to the second power. Well, do we agree when a fraction is raised to an exponent, for example, if I have 3/4 and I raise it to the second power, this becomes 9 over 16. The numerator gets that exponent and the denominator gets that exponent. So when I have x to the 2/3 over y to the half, y raised to the half power all raised to the second power, both the numerator and the denominator get that exponent of 2. So this becomes x to the 2/3 raised to the second over y to the half raised to the second. Power to a power you multiply, so I have x to the 4/3. What's a half times 2? 1. Has that taken care of the radical in the denominator? Yeah, luckily for us. So now I need to translate this back into radical form. So I have the cubed root of x to the 4th over y. Can I leave it like this? Why not? Good. We can pull out an x. So x times the cubed root of x over y. So remember in PEMDAS, I can always simplify what's in the parentheses first, right? So before I distribute that exponent of 1/3, I want to see if I can simplify what's in the parentheses. And I absolutely can. I have a minus 1 and then another a minus 1 in my numerator. And in my denominator, isn't that a dots? So I have an a plus 1 times an a minus 1, all raised to the now 1/3 power. So I can simplify and take out an a minus 1. We good so far? Okay. So now, what does this mean for us? This means I now have a minus 1 raised to the 1/3 power over a plus 1 raised to the 1/3 power. I can't leave it like this because a fractional exponent means a radical, and I can't leave a radical in the denominator. I'm going to opt to change this to radical right here. So I'm going to have the cubed root of a minus 1 over the cubed root of a plus 1. Am I going to treat this like a sum or difference of cubes? Like, is this a sum or difference of cubes? No, why not? It's only one term, right? Just this one radical. Is there a plus or minus something else here? No, so we're just going to treat this like a cubed root, which tells me to cancel out that cubed root. I need a grouping of how many? 3. I have one group of a plus 1. That means I need how many more? 2 more. So I'm going to multiply this whole thing top and bottom by the cubed root of a plus 1 quantity squared. So now in my denominator, I just have an a plus 1. In my numerator, I have an a minus 1 times an a plus 1 quantity squared. You do not need to multiply these. You do not need to multiply what's inside of there. If there was a plus sign between these two, would you then need to FOIL out and then combine like terms? Yes, but when it's strictly multiplication, you can leave it as factors. So this is where we stop. All right, next one. You guys try this one. What number is this? 3, 4? Oops. Remember last class what I told you about a numerical base and a fractional exponent. Try to remember what I had said to do. When you have a numerical base and a fractional exponent, there was something I recommended you do. Okay, so what you should have done, there was nothing to simplify within the parentheses, nothing I can do. So I'm going to distribute that exponent. So this is going to be 64 raised to the 2/3. Since it's multiplication, I'm treating them separately, times x to the 9th raised to the 2/3 over 27 raised to the 2/3 and y to the 12th raised to the 2/3. Everybody okay with my distribution of that exponent and why I was allowed to do that? All right, so now I had given you a very big hint. I had said, remember last class, what did I say to try to do, if possible, when you had a numerical base and a fractional exponent?
The numerical base might be a square root. So you can make that like 4 to the 3rd power.
Good. You want to try to change the base into something raised to the same exponent as the denominator. So can I make some 64 into some number raised to the 3rd power? Yeah, what number raised to the 3rd power? 4. So this becomes 4 to the 3rd power raised to the 2/3 power. And then we have x to the 9th raised to the 2/3. And in my denominator, can I change 27 into 3 to the 3rd raised to the 2/3? And then we have y to the 12th raised to the 2/3. So we can cancel out all the denominators, actually. The 3's cancel. Here, 3 goes into 9 how many times? 3 times. Here, the 3's cancel. And here, 3 goes into 12 4 times. So now we're left with 4 to the 2nd power, x to the 6th, 3 to the 2nd power, y to the 8th. Can I leave the 4 to the 2nd and the 3 to the 2nd like that? No, remember, if the exponent was 5 or less, you have to multiply it out. So this brings us to 16x to the 6th over 9y to the 8th. Can I simplify 16 over 9? No. So we leave it just like that. Can I divide 8 and 4 and get 2 as my radicand? Good. Why can't I divide them? Stephen? They don't have the same index, so I can't. Okay, so I'm going to change this to exponential. I have 8 to the 1/6 over 4 to the 1/3. And I had said before, if possible, change your numerical base into something raised to the same exponent as the denominator. But is that possible in this scenario? Can I make some number 8 into some number raised to the 6th power? No. Can I make the 4 into some number raised to the 3rd power? No. There's other things though. The other things we can do is the rule says when we're dividing, if we have the same base, we can subtract the exponents, right? But I don't have the same base. Is there a base that I can turn them both into, though? Yeah, what base can I turn them both into? I can't turn them into a 6, no. 2, I can turn them both into 2. So 8 becomes 2 to the 3rd power raised to the 1/6 power. 4 becomes 2 to the 2nd power raised to the 1/3 power. So now I end up with 2 raised to the 3/6 power over 2 to the 2/3 power. Now the rule says keep your base and subtract your exponents, but I could only subtract the exponents if the denominators were what? The same. Can I make it the same denominator? Yeah, I'll make a denominator of 6. So then this, I'll bring it down here now. I'm going to have 2 to the 3/6 over 2 to the 4/6. And now I can divide. Where is my quotient going? In the numerator or the denominator, and how do you know? Arav? Yeah. So since 4/6 is bigger than 3/6, it always goes wherever it is bigger. So we're going to have 2 to the 1/6 in my denominator and 1 in the numerator. So now we've simplified this a lot, but can I leave it like this? No, 1/6, the exponent represents a radical. I can't leave a radical. So I need to rationalize. So I'm going to get to the closest whole number. What's the closest whole number here? 1. So what? 2 I need to get 6 over 6. So what am I going to do to get to 2 raised to the 6 over 6? Multiply by 2 raised to the 5 over 6 power. So this becomes 2, and this is 2 raised to the 5/6 power, which is going to be the 6th root of 2 to the 5th over 2. Do I have to multiply 2 to the 5th power? Yes. So we have the 6th root of 32 over 2. All right, next one. Yes. Okay, let's say I had x to the 3rd divided by x to the 4th. So the rule says as long as you have the same base, you keep your base and you subtract your exponents, right? So when you subtract 3 and 4, there's more 4s on the bottom than there are on the top. So there's only 3 x's on top, but there's 4 x's on the bottom. So your quotient always goes wherever the exponent is bigger. So we knew 3 minus 4 would be 1, but 1 where? In the numerator or the denominator, wherever the bigger exponent is. Does that make sense? Okay. Okay, let's keep going. I don't know if we're going to finish. See, but you'll have enough to do your homework. Homework? I think 18 or 19, but some of them are real quick ones. All right. Can I distribute in that power of 1/3? No, why not? Because of the plus sign. So we need to try to work within our parentheses. What do you think I'm going to recommend we do? I can't add them. Yeah, get rid of the denominator. So here we're going to have 4 to the second raised to the 5 halves plus 5 to the second raised to the 5 halves, all raised to the 1/3. This cancels and this cancels. So now we have 4 to the 5th power plus 5 to the 5th power, all raised to the 1/3 power. I don't know what this is, guys. Do you? What is it? I don't know. I meant to put those as exponents of 3. Just tell me the total sum. I meant to have these be exponents of 3s, not 5s. That's the problem. Okay, well, it's going to be some quantity to the 1/3 power, but then we'd have to find the pairs. But this was supposed to be 3, so it wasn't supposed to be as bad. It was supposed to be like this. So then it should have been 64 plus 125. But then you were still going to have to simplify the, yeah. Yeah, I won't give numbers that bad, like the 5th power one that Arav is still trying to figure out what the product is. What is it? 4149. Okay, well, anyway, then you would have the cubed root of 4149, but then you'd have to start looking for triplets. But I won't give you problems that high. Don't worry. Don't be sad. All right, next one. I just wrote down the wrong problem initially. That's why. Oh, guys, I'm jumping around. I'm trying to find the important ones. That's a -1/2 here. Fun? Okay, so first thing I'm going to do is we can simplify root 125 easily in our head, right? Isn't that 5 root 5? And then I have 3 over the square root of 2. And then I'm going to switch this negative exponent. So I'll have 16 over 5 raised to the 1/2 power. Are we okay? So far, so good? Okay. So now I have 5 root 5 minus 3 over root 2 plus the root of 16 over the root of 5. Still okay? Do we all agree in order to add or subtract, I need a common denominator? But before I decide the common denominator, what did I tell you to do? Rationalize. So are you guys also okay if I make this root 16 just 4? Okay, good. So I'm going to rationalize here. Square roots are so easy now to work with. You just multiply it by top and bottom by itself. So this becomes 5 root 5 over 1 minus 3 root 2 over 2 plus 4 root 5 over 5. Am I going too fast or are you keeping up? Now we need a common denominator. What's our common denominator? 10. So this is 50 root 5 over 10 minus 15 root 2 over 10 plus 8 root 5 over 10. And now we keep our denominator of 10 and we add our like radicals. So I have 50 root 5 plus 8 root 5, which is 58 root 5 minus 15 root 2. Nothing I can do there, so I leave it like this. So the hardest problem that you also really need to know, I haven't gotten to, so you have to remind me to do this problem next class. Okay? All right, we're done for today.